Happy Monday, everybody. Here is our second video lecture. It is the last lecture you're going to get before your test tomorrow. I hope it is helpful. Today we're going to quickly learn about biochemistry. I'm going to start by going over how to do energy levels and orbitals. We took these notes really fast in class, and I feel like if you are someone who hasn't had chemistry since 9th grade, it might have been a little bit fast for you, and so I'm going to go over this. Feel free to skip this next part if you don't need it, if you took AP Chem or regular Chem last year and you felt like you really understood it. Here we go. The four most important atoms for living things are hydrogen, oxygen, nitrogen, and carbon. I also include phosphorus here because it makes up a lot of your DNA, but it doesn't follow the same bonding rules as HONC. If you can remember HONC, it will be really helpful on your test. I'm going to show you how to do the energy levels for each of these, so feel free to follow along. We start with the periodic square. These will be provided for you on your test, and we're going to start with this. We're always going to look for the number up top, which is the atomic number. The atomic number tells us how many electrons each molecule has, and we're going to need that for this to draw the energy levels. We always start with the symbol, and then we draw an energy level around the outside. We then look and see how many electrons it has. So hydrogen has 1 electron, and so I need to go ahead and put 1 electron on the outside of this molecule. My computer's being a little funky. Okay, so it has 1 electron. We go back to our number of electrons. We had 1, we've used 1, and we have none left, so we know we are done drawing. The number of electrons we end with in that last shell is the valence electrons. So for valence electrons here we have 1. And then we have to say how many open spaces we have to figure out how many bonds we can make. Hydrogen has 1 electron. The first energy level holds 2 electrons, and so we have 1 open space to put another electron, and so hydrogen can make 1 bond. Okay, moving on to oxygen. We start with oxygen up here. We look at the top number, which is 8. And so we know we have 8 electrons. Okay. Then need to start with the oxygen symbol in the middle. And our first energy level. We talked just a second ago about how the first energy level can hold 2 electrons. And so we're going to put 1, 2 electrons on it. Now we've used 2 electrons. Okay, we have 6 electrons left to go, and so we need to move out to another energy level. Okay, in this energy level we need to put 6 electrons. 1, 2, 3, 4, 5, 5, and 6. Okay. And since that's our last orbital, we have our valence electrons equaling 6. And then the second energy level can hold 8 total. So we have 1 open space, 2 open spaces, which means we can make 2 bonds. Okay, moving on to nitrogen. Nitrogen's atomic number is 7. Which means for nitrogen we have 7 electrons to work with. We start with our symbol in the middle and go to our first energy level. Our first energy level can hold 2 electrons, and so we take and we put 1, 2 electrons in our first energy level. We then go here, we've used 2, which means we have 5 left for our next level. We have to go out to our next level. We put 5 electrons in our outside level, 1, 2, 3, 4, 4, and 5. And we are out of electrons, so that outer level has 5, so we know our valence electron number is 5. And the second energy level, as we talked about, can hold 8. So we have 1, 2, 3 open spaces. Whoops, sorry about that, guys. 3 open spaces to form bonds. Okay, on to our next one, which is carbon. Carbon has an atomic number of 6, which means we have 6 electrons. We start with our atomic symbol in the middle, which is a C for carbon, and then we go out to our first energy level. Our first energy level can hold 2, so we do 1, 2 electrons. Okay, we started with 6, we've used 2, which gives us 4 electrons left for the next energy level. We go out to that next energy level, and we add 6 electrons. 1, oops, I don't know why that isn't working. 1, 2, sorry, 4, 3, 4 electrons. That second level can hold 8, and that leaves us 1, 2, 3, 4 spaces for bonding. So valence electrons, we have 4. Bonds that carbon needs to make, we have 4. Okay, so if you are noticing, if you can remember honk, hydrogen makes 1, oxygen makes 2, nitrogen makes 3, and carbon makes 4 bonds. Makes it easy to remember. Okay, last we have phosphorus. Phosphorus doesn't follow that order, but I wanted to show it to you because it is important for humans and life because it is part of DNA. Phosphorus has an atomic number of 15, which means we start with 15 electrons. Okay, we have our atomic symbol in the middle and our first energy level. Our first energy level holds 2. 1, 2. We started with 15. We've used 2. We have 13 left. Okay, this is the first time we've ran into this. We have 13 left, but the second level only holds 8. And so for the second level, you need to fill it up. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. We started with 15, we had 13 left, we've used 8 more, which means we need to go out to another energy level because we still have 5 left. Okay, we go out to another energy level. Sorry, I have some overlapping here. Getting tight on space. We have 5 left. 1, 2, 3, 4, and 5. That gives us, if we count our outer ring, 5 valence electrons, which leaves us 1, 2, and 3 spaces to make bonds. So phosphorus can make 3 covalent bonds. Now we're going to move on to drawing molecules. Once again, we did this in class, so if you already know how to do this, you don't need to do it again. Feel free to skip it, but if you haven't taken chemistry in a while, I suggest you watch it just as a reminder. I'm going to draw 2 molecules for you guys. The first one's a little bit more simple, and the second one is more complex. When I'm drawing molecules, I use my honk as a reference, and I always start backwards with the most bonds to the least. So I'm going to start with carbon because carbon makes 4 bonds. And I ask myself, how many carbons does my molecule have? This molecule has 3 carbons. And so I'm going to start by drawing my carbons. First carbon, carbon makes 4 bonds, so I've drawn 4 bonds. Second carbon, this carbon already has 1, 2, 3, 4 bonds. Third carbon, 1, 2, 3, 4 bonds. Now I'm done with carbon. I move on to my nitrogen. This molecule has no nitrogens, so I don't need to do it. And so I can cross off my nitrogens. I don't know what I just did. Okay, so we don't need any nitrogens. Also doesn't have any oxygens. And here we have 11 hydrogens. So I'm going to start making hydrogens here. Okay, that's 1 hydrogen. Oops. 2 hydrogens. Oops. Sorry guys, I'm trying to make this go faster and I don't think it is. Three hydrogens. Four hydrogens. 5, 6, 7, 8. And I clearly messed up on my equation because there is only 8, and that's what I meant. Sorry about that. Should not be 11, there should be 8 hydrogens. Sorry about my mistake. We then can count covalent bonds. Each line counts as a covalent bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 covalent bonds here. Okay, hopefully I didn't mess up on this one. Moving on to the next equation. Start over with my honk. Okay, I start with carbons. We have 2 carbons, and so I draw 1 carbon, 2 carbons. I give each carbon 4 bonds because carbon has to make 4 bonds. And then I am done with carbons. I move on to nitrogens. There's 1 nitrogen. Nitrogen makes 3 bonds, and so I give the nitrogen 3 bonds, and then I'm done with my nitrogen. I have a weird thing here, okay, with the OOH. I'm going to move on to oxygen. I see I have 2 oxygens, so I'm going to go ahead and put 1 oxygen on there. Doesn't matter where you put them. A second oxygen on there. Each oxygen needs 2 bonds. And because one of the oxygens is directly by an H, that means it has to be touching one of the hydrogens. So I'm going to go ahead and I am going to put a hydrogen on that oxygen. I'm now done with my oxygens, and I see I have 4 hydrogens left. Okay, I'm going to go ahead and start here. 1, 2, 3, 4. Okay. You can see I'm out of molecules now, and the O needs another bond, and this C needs another bond. And so what you would do in that case is you would double bond your C to your O. And that would fulfill it. Carbon has 1, 2, 3, 4, and this oxygen has 2. You could have drawn it differently. Okay, if you put your hydrogen around this way instead, 1, 2, 3, and if I put this hydrogen on this oxygen, that would have worked as well. Then I have 2 carbons that have open bonds, so we would draw our double bond here instead, getting rid of these 2 lines. Okay, that sums up drawing molecules. Hopefully that made sense. Once again, sorry about the mess up here. Last thing to do is count these covalent bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 covalent bonds in this molecule. Okay, now we're moving on to new stuff, so everybody needs to take notes in your notebook on this next slide. We are going to talk macromolecules. Macro meaning big molecules. Oops, sorry. We're going to start with polymer versus monomer. Okay, a polymer is a large molecule, poly meaning many, and it's a large molecule made up of many smaller molecules. Comparing that to a monomer is a molecule made up of atoms covalently bonded together. Mono meaning one. So here you have one molecule, here you have a large molecule made up of small molecules. I'll give you an analogy. Analogy would be a polymer would be an entire book, and a monomer would be all the pages of the book. In bio, we only deal with 4 polymers, and we'll talk about them on the next page. In our case, macromolecules are our polymers, and the pieces they're made up of are the monomers. So let's go ahead and take a look at those. There are 4 polymers you need to know, and at this time, you only need to know their monomers. The first polymer is a carbohydrate, and its monomer is monosaccharide. Carbohydrates, an example would be bread, pasta, anything from that bottom of the food pyramid. And monosaccharide means one sugar, and all carbohydrates are made of small molecules of sugar. The second polymer-monomer mix you need to know are lipids, and their monomer is fatty acids. If you watched the other video, you might have seen that they said that lipids don't have monomers. A lot of people don't count fatty acids as a true monomer because they're compared with, also paired with glycerol. But for our case, fatty acid is going to be the monomer for lipid. You can think of anything that has fat in it, grease, oil. Those are all lipids. Third polymer or macromolecule are proteins, and their monomers are amino acids. Things with proteins are meat, nuts, seeds, soy, all have a lot of protein in them. They're all made up of amino acids. And last, we have nucleic acids, and their monomer are nucleotides. Nucleic acids are what your DNA, it's the category that DNA is. So DNA is the macromolecule group nucleic acid, and DNA is made up of nucleotides. At this time, that's all you need to know about macromolecules. As we get more into the different units, we'll talk about each of these in turn. We'll talk about carbohydrates when we get to the energy unit. We'll talk about lipids as they surround each of your cells. We'll talk about proteins when we talk about making proteins. Proteins are very important for your body. And we'll talk about nucleic acids when we talk about our body's DNA and how we replicate it. The last thing we're going to take notes on is the pH scale. If you have taken chemistry, you might have learned a lot about pH, especially if you took AP chemistry. For this class, we don't need to know too much about pH. The pH scale goes from 1 to 14, and pH is a measure of how acidic or basic a solution is. Solutions are anything that are liquid. So, from 1 to 7, okay, from 1 to 7, we have acids. Okay, so anything from 1 to 7 will be an acid. And actually 1 to 6.99999 repeating. Right at 7, we have pure water, and that is neutral. And then anything above a 7, so 7.01 and up to 14 is a base. At this time, that's all you really need to know about it. Okay. Acids, some typical acids in your household are lemon juice. You might have, that's the big one, pop is acidic. Okay. Coca-Cola is acidic. It's one of the most acidic ones, pops. Over here at the base side, bleach is basic. Some different, I think, juices are basic. I can't remember which ones. Your laundry detergent's probably basic. Okay. And then neutral is pure water. And that's all for me today. I hope you have a wonderful Monday, and feel free to come in for help on your test tomorrow if you need it before your test. Otherwise, thanks for watching, and I will see you tomorrow.